Hello, everyone. This is Dr. Scott Haggerty, and tonight I want to start diving into one of my favorite personal topics, brain laser therapy. As we start off, I'd like to ask you something. Have you ever had a moment where your brain just did not feel like it was your brain? Not broken, but not sharp. Not calm, but not out of control either. Just off. Maybe it showed up as things like brain fog. Maybe you had some anxiety. Maybe it was your child having some inability to focus or self regulate or to sleep well. What if that feeling isn't random? What if it's not just behavioral? What if it's actually biological? We have been trained to think of the brain as a purely psychological organ, thoughts, emotions, behaviors, but underneath all of that, the brain is always a biological system. And more specifically, it is an energy dependent electrical system. So your brain is only about 2% of your total body weight, but it consumes about 20% of your total energy every single day of your life. And studies have shown this, right? There was a study that was done by Keaty and Schmidt back in 1948 that was the first one that really showed this energy consumption. They've confirmed it in multiple different settings, by things like modern PET scans, where they measure glucose uptake. And if you think about this, this is an enormous energy demand, which means something very important. The brain doesn't just need energy. It needs consistent, high quality energy delivery to function properly. So, literally, every thought that you have, every memory, every emotional response is dependent upon electrical signaling between neurons. And those electrical signals depend upon ion gradients, membrane potentials, and ATP driven pumps, specifically the sodium potassium ATPase pump. Now, what happens when ATP production drops even a little bit? Neurons don't immediately just fail, they become inefficient. The signaling from neuron to neuron slows, noise in the brain increases, timing becomes inconsistent, and recovery between signals decreases. Over time, that inefficiency becomes what we then later call symptoms. So tonight, I want to explore something with you. What if many of the challenges we're seeing are not primarily chemical, but bioenergetic problems? And if that's true, then what would happen if we supported the brain at that level? Now, let's go one layer deeper. What does a neuron actually need to function? It needs oxygen, glucose, functional mitochondria, and ATP. Because ATP is ultimately the currency of the brain. ATP powers ion exchange, neurotransmitter release, synaptic plasticity, axonal transport, and without ATP, neurons cannot maintain their stability. When ATP drops, the brain doesn't shut off. It becomes inefficient, unstable, and inconsistent, which shows up then as poor focus, emotional dysregulation, fatigue, and sensory overload. When you look at research studies that have been done on brain energy, there was several that have really dove deep into this, especially one by Mosconi that was done back in 2008. And simply put, the researchers used PET scans to dive deep into brain glucose metabolism. And they found that reduced brain metabolic activity in key regions was critical in later onset of signs and symptoms. Specifically, this was a study that was diving into symptoms of later onset of Alzheimer's. They showed that there was a significant decrease in energy production years before Alzheimer's symptoms appeared. This is incredibly important to us because it tells us that energy declines before function declines. So, what if we've been looking at this all backwards? What if instead of asking, what diagnosis is this? What if we more specifically asked, how is the brain being fueled? So think about it like this, right? Think about your child or yourself. Think about the moments where things feel the hardest. What if those moments where the brain is most underpowered, where this is what you're feeling? What if the brain just does not have the energy to quite literally handle the situations that you or your child or your family members are in? This is critical because we need sufficient energy at all times for our brain to do the tasks that we asked it to do every single day. So let's go even deeper. Inside every neuron are mitochondria. We've established this. These are the engines of the brain. Mitochondria produce ATP through a thing called the electron transport chain. The final step of this process is controlled by an enzyme called cytochrome C oxidase complex 4. This enzyme is critical because it is where oxygen is finally used to produce ATP. Cytochrome C oxidase has a very unique property. It can absorb light because you are biologically designed to respond to photons. So in a study that was done by Wang and Riley in 2005, they exposed neurons to near infrared light. And when they did this, they found increased cytochrome C oxidase activity, increased intracellular ATP production, and improved neuronal survival when under stress. And this is huge because when neurons are stressed, they don't die immediately. They can struggle. If we can support mitochondrial function, we can improve how those neurons perform when under stress or in normal situations. In another study that was done by Karu in 1999, she proposed that light absorption alters mitochondrial redox states. And this influences directly ATP production, cellular signaling, and gene expression, or the ability of these cells to reproduce. So if a neuron suddenly has more ATP available, then what now happens to its ability to fire? What now happens to its ability to recover from stressors? What happens to its ability to self-regulate? See, when we use brain laser therapy, we are not forcing the brain to change. We are giving it the energy that it needs to be able to function properly. And this is massive. Because when you look at the brain's function, right, it gets really interesting. When you look at how this all works, when you see like the interplay, right, it gets super interesting because there's things like nitric oxide, and it plays a major role in mitochondrial function. But it also does something else. It regulates blood flow. See, nitric oxide binds to cytochrome C oxidase, which temporarily inhibits respiration. Okay. Now, when it is exposed then to light then causes the release of nitric oxide, which improves vasodilation. It also increases ATP production and it improves oxygen utilization, all as a result. In another study that was done by Hamblin in 2016, they had a similar finding when they did a bigger review, and they found across all these studies, there was this consistency. When the brain was exposed to infrared and near-infrared light, there was improved mitochondrial respiration, improved NO signaling, improved blood flow in the cerebrum, and improved ability to handle oxidative stress. This is huge. Another one that was done in 2010 used a thing called near-infrared spectroscopy. And again, similar findings. They found increased blood flow to the prefrontal cortex, the area that controls executive function, which then led to improved cognitive task performance. So here's what we're seeing as a trend. If blood flow improves, if oxygen delivery improves, if ATP improves, brain function improves. So think about brain fog. Think about the heavy, slow, tired feeling. Think about the child who melts down when they're overwhelmed. What if part of that is a brain that simply doesn't have enough fuel in that moment? Now, I know some of you are probably thinking, like, this sounds interesting, but how does the light that we are shining actually reach the brain? And this is a fantastic question. Because what we have several barriers. We have skin, we have fascia, we have skull, and we have cerebral spinal fluid. Light must pass through all of these. So penetration depends upon the wavelength, the power density, and the pulse structure. There was a study that was done in 2012, and it was by a group of researchers. It was Jagdeo and others. And they found that near-infrared light penetrates multiple centimeters deep into the tissue. The variability to this are things like skull thickness, tissue composition, and the angle of delivery, which is obviously a big deal when you're actually doing this because you have to have the correct amount of power, correct angle of delivery to get the target tissues. So there was a study that was done on stroke models by Lapchak and De Taboada. And what they found is that in people that had strokes and they exposed the brain to near-infrared light, it improved neurological outcomes dramatically. And all of these mechanisms were shown to be tied to mitochondrial function because it protected the cells. Now, here's the issue, though, is not all light is the same when you're doing these types of things. And many of you have seen this, right? If you go onto any online platform, you're probably seeing all kinds of infrared devices. So these low power LED systems that you see on Amazon and other places, what they do is they scatter at the surface and they have very limited depth of penetration. What we use in our office here is a class 4 laser. And so these class 4 laser systems like we use, they have what's called higher photon density, which leads to deeper penetration through the skull and more meaningful cortical interaction. And so this is obviously a big deal because if the goal is to influence brain metabolism, do we need surface light or do we need sufficient energy delivery to the deeper structures? And I think it's obviously, that we need deeper delivery, right? We need power that can penetrate through the skull to fluid into the brain tissues. Now that we understand how light reaches the brain, the question becomes how much is the right amount? Because in biology, more is not always better. Photobiomodulation follows what is called a biphasic dose response, and this has been studied extensively. So one of the most cited reviews on this is by Dr. Michael Hamblin and Dr. Tatiana Demidova, and this was a review that they did back in 2006, and it was a review on low-level light therapy. And what they found is that after reviewing dozens of cellular and animal studies, they found this consistent pattern. Low dose led to no response. Optimal dose led to increased mitochondrial activity, and high dose led to inhibition of cellular function. So you really have to dial it into the right levels. So this isn't just shine the light on the head and hope for the best. This is what's called dose-dependent neurobiology. This is also the whole reason why we use pulsed light instead of continuous light. Simply put, continuous light leads to heat buildup, too much power, cellular inhibition. Pulse light allows us to have bursts of energy and periods of recovery. So the brain is much more amicable to pulse light. So instead of overwhelming the tissue, we're delivering energy in a way that the biology can directly respond to it. So if your brain is sensitive to both energy and timing, what happens when we control both? Well, this is where things start to get really interesting. So we're going to shift gears now because energy is really only half the story. The brain is also a rhythm-based system. So neurons don't fire randomly, they fire in patterns. These patterns are called brain waves. And there's several different brain waves that we examine on the regular. Things like delta waves, which are associated with deep sleep and restoration. Theta, which is deeply associated with memory, learning, and relaxation. Alpha, which is related to calm and regulated focus. Beta, which is states of alertness, active thinking. But there's another layer to that I want to add in. There's low beta, which is when we're alert but calm. And there's high beta, which is stress and anxiety. And so many of you, if you're dealing with stress and anxiety, you may be locked into high beta. This is going to get very important for you. And there's also gamma, which is directly correlated to integration of information and high-level processing. Now, what happens if those rhythms begin to lose coordination? Well, communication between the brain regions then becomes inefficient, and that will show up also as things like poor focus, emotional instability, sensory overload, and difficulty self-regulating. So think about a child who melts down in loud environments, or think about someone who can't turn their brain off at night. What if that is part of the brain that has completely lost its rhythm? And we see this all the time because this is a huge issue that many people are I would say the word suffering with. Is when the brain loses rhythm, we have symptoms that we don't know why they're there or what to do about them. But in many cases, it is this timing that has been lost in the brain. So this becomes important for us because here's where things get super interesting. The brain doesn't just create rhythm, it can respond to rhythm. This is called the frequency following response. And you've experienced this before, we all have. Music changes your mood, your breathing patterns calm your body, and repetitive rhythms directly affect your state. Think about your favorite relaxing music. When you listen to something relaxing, your mental state changes almost immediately. And this has been studied extensively in neuroscience, especially in auditory and photic stimulation research. So when you connect this into light stim directly, like with brain laser, if the brain can synchronize to rhythm and we deliver light and rhythmic pulses, what do you think is going to happen to the brain? See, this becomes important because if we can entrain the brain, then we can alter brainwave patterns. And what's neat is this is not controlling the brain. This is not forcing the brain into a state. This is giving the brain a pattern that it can respond to that is more appropriate for what the brain needs to do. So if energy fuels the brain, rhythm organizes it. Now, let's look at one of the most important discoveries in modern neuroscience. And when you hear this, Like, I read this study for the very first time a few years ago, and my mind was just blown. In a 2016 study, a team at MIT led by Dr. Li Hui Tsai published a study in the journal Nature. And what they did is they exposed mice with Alzheimer's disease pathology to 40 hertz gamma frequency light stimulation. So they took a laser, dialed it in at 810 nanometers, and pulsed at 40 hertz. What they found was just unreal. They found three major changes that are relevant: activation of what are called microglia, the brain's immune cells; reduction in what's called amyloid plaques, the main plaques that build up in the brain in Alzheimer's; and improved neuronal function. So what this literally means is microglia are the brain's cleanup system. When they function properly, they remove damaged proteins and debris, the byproduct of buildup in the brain that leads to Alzheimer's symptoms. So this study showed that rhythmic stimulation at 40 hertz could influence the brain's ability to clean itself up. Now, listen, let's put this in context. It's early stage research, but it completely changes how we think about brain rhythms and what we can potentially do with brain laser therapy to help to improve brain function. So what happens if the brain then becomes better at maintaining itself? Let's take this to another level. When we bring this into real life and we start talking about things that are very real today, right? Autism, we know, is an epidemic, right? 1 in 36 kids in the United States has been diagnosed with autism. There was a study that was published in 2018 by Leissman and Machado. So this study was in the journal Advances in Experimental Medicine and Biology. And here's what they did. They took children diagnosed with autism spectrum disorder and applied transcranial photobiomodulation over a treatment period. That treatment period then was measured. So what's important is that when they did this treatment, they saw, it's not just they saw improvement, it's how much improvement that they saw. So I'm going to break this down for you because I think it's important to understand the context of what was being measured. They had several different parameters to this to make this a more pertinent study for children on the spectrum. The first thing they used is something called the Aberrant Behavior Checklist, or ABC. This is a validated tool to measure behavior changes in autism. So here's what what happened in the active treatment group. The total ABC score dropped from 107.3 down to 63.8. That is a 43.5% point reduction. Meanwhile, the placebo group stayed essentially the same, actually increasing from 104.7 to 105.4. That is not subtle, the changes in the treatment group. Now, let's look at irritability, because this is one of the most challenging symptoms for families of children on the spectrum. The active group started at 30.5 and reduced to 15.7, nearly a 50% reduction during the treatment phase. The placebo group essentially stayed the same, no improvements. The study actually reports an adjusted difference of 15.2 points with a statistical significance of a p-value of less than 0.0001. That's huge. Now, here's what matters even more to parents. 86% of the children in the treatment group had at least a 25% reduction in irritability. That's massive. So the placebo group showed 0% change. And when they looked at overall responders, 81% were considered positive responders compared to 0% in the placebo group. So what does that mean in real life? This wasn't just a slight improvement. This was a large percentage of children experiencing noticeable behavioral changes. So let's step out of the numbers for a second, because those numbers represent something very real. Imagine a child who used to go from calm to meltdown in seconds. And now there's a pause. Instead of them going from 0 to 60, it gives them a moment to regulate themselves. Imagine a child who couldn't sit through dinner. Now they're able to sit at the table. Imagine a parent who used to feel like they were walking constantly on eggshells, and now there's just a little bit more peace at home. That is what a 40-point drop on that scale actually looks like in real life. It is a tangible quality of life change for these families that was sustained. And here's the cool part. They observed improvements in behavioral responses, improvements in cognitive function, measurable EEG changes. Now, what that means is EEG measures brainwave activity. So when EEG improves, it means the brain is becoming more organized and more coordinated, like we talked about earlier. There was also another study, and this one I found fascinating. It was a study on children with Down syndrome. And it looked at individuals with Down syndrome receiving transcranial photobiomodulation, and they found tangible improvements in improved attention, improved memory, and improved adaptive behavior. So, what does this mean? Well, in children who have Downs, this means that maybe their brains are underpowered. They're not getting enough energy production. Maybe they're inefficient, and maybe they're out of sync. So if you're a parent of any of these children, right, what would that mean? If the brainchild could process the world more clearly, that's going to be a huge benefit, because anytime that you're able to produce more energy in the brain, and it responds by being able to handle stress better, better memory, better cognitive performance. That's a huge benefit for everyone. Now, let's shift the conversation from children to all of us, because this isn't just about neurodevelopment. This is about how the modern brain is functioning under stress. So, how many of you feel like your brain is having a harder time shutting off than what it used to? Or, you feel more overwhelmed with things that didn't used to overwhelm you? When we talk about anxiety and stress, we're talking about how the brain regulates itself. Because, put simply, you have this thing called the limbic system, which is what the great regulator of your emotional and stress responses. Your prefrontal cortex controls self-regulation, and your autonomic nervous system teeters back and forth between the parasympathetic and the sympathetic system, going from stress to rest and recovery. So when the brain is underpowered, the prefrontal cortex cannot regulate effectively, and the limbic system becomes more dominant. Now, interestingly enough, there's lots of studies that have been done on this, but this one study I want to point out, it was a depression study. And there have been clinical studies looking at transcranial photobiomodulation in depression. And what's neat about this is participants with depression receive this light therapy over a period of several weeks. And in the study, they observed significant reductions in depression scores, improvements in mood regulation, and sustained improvements over time. This suggests that improving brain energy and blood flow may help restore the brain's ability to regulate mood. There was another one that was done on stress and anxiety, and it looked specifically at how they responded to brain laser therapy as it related to specific stress markers. And they found that there was a marked reduction in stress markers, improved emotional stability, and improved resilience. These are all huge findings, because that means better quality of life, less anxiousness, less fluctuation in mood. So for the children, for the parents, everybody, this is going to be a huge benefit. Now, I want to connect this to something that many of you have heard of. There's this thing that is called the vagus nerve. And so this polyvagal system, this is huge for the way that our brain works. So there was this theory called polyvagal theory that was developed by Dr. Stephen Porges. He describes how the nervous system shifts between states of safety and survival. And there are three primary states. There is this state called ventral vagal, which is when we are calm and connected. There is the sympathetic response, which is fight or flight. And there's the dorsal vagal, which is when we shut down. Here's why this becomes incredibly relevant. There was a study done by Machado and colleagues and looking at the effects of low-level laser stimulation on vagal activity. They measured something called heart rate variability. And if you are a patient at our office, you are familiar with heart rate variability. But HRV is one of the best markers of how we are able to measure nervous system flexibility. Higher HRV equals better regulation, better stress tolerance, and better recovery. And here's what they found. After laser stimulation, HRV notably increased and parasympathetic activity notably increased. So what does this mean? It means that the nervous system becomes more capable of shifting out of stress and into regulation. So what does improved vagal tone actually feel like? It feels like your body doesn't overreact to everything. It feels like it can handle stress without it overtaking you. And it feels like your child can transition better between activities without every single thing turning into a battle. So what would this mean for someone that is dealing with anxiety, chronic stress, emotional reactivity, poor sleep? Well, here it is. If the brain can regulate better, you're going to have better responses to stress and anxiety. So it makes us pause and say, what if anxiety isn't just psychological, but partly a brain that doesn't have the energy to regulate itself and it's out of rhythm? And this is where you have to look at this and say, this can be a massive, massive finding for folks who are dealing with this on a day-to-day basis. So let's take a look at something else. So when you take this one step further, this isn't just about fixing problems, right? It's about optimizing performance. So when I looked at some of the study data, some of the things that were on here were just fantastic. there was a systematic review and a meta-analysis that was done, and it was called Transcranial PBM Improves Cognitive Performance in Healthy Adults. And so, in essence, what it meant was that when you look at the overall way the brain responds to photobiomodulation, there is this massive improvement in the brain's ability to perform cognitive tasks. And this wasn't a huge study; it was 14 young adults, but it showed this effect of 0.83 effect, and after adjustment 0.94. This is a huge number because in research terms, this equates to a moderate to large improvement. They found improvements in things like working memory, attention, processing speed. These weren't people with brain injuries. These were healthy individuals. So what does that tell us? If you improve brain energy, you don't just fix dysfunction, you enhance function. And think about this. What would it feel like to be able to think more clearly on a daily basis, to remember more easily, to stay focused longer? This is where where brain health becomes performance. Now, let's look at what happens when the brain is injured. There are studies that are looking at photobiomodulation in TBIs, traumatic brain injuries. In one study, they measured cerebral blood flow and cognitive function. And in individuals that were in this study, they found that there was a noticeable increase in cerebral blood flow velocity, more blood flow making into the brain faster. There was tangible improvements in executive function, which led to big increases in recovery and improvements in memory. Specifically, there was left-sided blood flow increased by 19%, and cognitive performance improved with faster task completion and better recall scores. So what does that tell us? When you improve energy and circulation in a brain that has been injured, the brain is able to recover more effectively and at a higher upside. Now let's talk about something that affects every single one of us, aging. As the brain ages, we see mitochondrial decline, reduced blood flow, increased oxidative stress, and reduced repair capacity. Now, I want to show you something that I think is one of the most fascinating areas of research. So, when you look at some of these reviews, right? So there was a review that was titled "Shining Light on the Head: Photobiomodulation for Brain Disorders." This paper looks specifically at how light therapy affects conditions like Alzheimer's. And let's start with what they found. So there was a small controlled study, a single blind pilot study with 19 patients. These were not mild cases. These were individuals with a moderate to severe cognitive impairment with an MMSE score between 5 and 24. Now, what I want you to understand is the MME score, it means mini mental status exam. It's a standardized test used to measure cognitive function. So a normal score is 30. So a score of 5 to 24 represents significant cognitive decline. Over a 12-week period, they used a combination of transcranial and intranasal photobiomodulation. And so what they found was an average of a 5-point increase in MMSE scores. And let me translate that. In Alzheimer's research, a 2 to 3 point change is considered very meaningful. This was a 5-point improvement, and that is not subtle. They also saw improvements in what are called ADAS COG scores. So that's another standardized test used in Alzheimer's clinical trials, and it measures memory, language, and cognition. So we're seeing improvement across multiple validated cognitive scales. And they also saw things like behavioral changes. And here's where it becomes very real. The caregivers reported better sleep, fewer angry outbursts, less anxiety, reduced wandering. Think about that for a second. That's not just better test scores. That's a very different daily life. Now, here's something I want you to pay attention to. When they stopped the treatment for 4 weeks, some of those gains began to decline. That tells us something very important. This isn't forcing a permanent change. It's supporting an ongoing biological process. Just like exercise supports the body, this appears to support the brain while it's being applied. And importantly, they reported no adverse events related to treatment. So what we're looking at something that is non-invasive, well-tolerated, biologically active, and it shows meaningful change. So tonight we talked about a lot. We've talked about a number of different things that are very relevant to all of us. We've talked about energy. We've talked about mitochondria. We've talked about blood flow. We've talked about brain waves. We've talked about synchronization. We've talked about research. But I want to bring this back to something very simple. What if your brain is not broken? What if it's simply underpowered, inefficient, and slightly out of sync? And what if by supporting energy and timing, that brain could do what it was designed to do? Think about yourself or your child. Think about the moments that feel the hardest in your day-to-day life. What would change if the brain could more easily regulate itself? What would change in your home? What would change in your relationships? What would change in your work? What would change in how you feel every day? See, ultimately, this is not about forcing the brain. This is about supporting it. And when you support biology, sometimes it just does something remarkable. Hope you enjoyed the presentation. I hope you enjoyed this information. I would love your comments and your feedback on what you would like to learn more about. So drop those in the comments here below so we can continue to expand this conversation and help to go and teach more people about the amazing ability of brain laser to help to improve their quality of life. God bless you guys, and we'll see you in the next video.